read as AN is way less than BN for very large values of N. So it works kind of like your direct comparison test. So how could I modify this so that I can conclude something?
BN converges.
Yeah, if BN converges,
then AN converges.
Then that means AN converges, right?
Mm-hmm.
Okay. Okay, so what if BN diverges? What would have to happen to get AN to diverge?
It's bigger than half.
Yeah, if this went to 1 or if this went to infinity, right?
Mm-hmm.
So if this went to infinity or 3 or 1/2, any of those things would show, right? Because that's saying asymptotically, AN is at least keeping up with BN in these two cases, or it's blowing up way bigger than BN in the infinity case, right? So you would read it that way, right? If the limit is 0, you can assume that the top is much smaller than the bottom. If the limit is infinity, you can assume the top is much bigger than the bottom, right? So that's your intuition for dealing with those things. Yeah, so I've seen people get burned by that 0 infinity case a couple of times. I don't remember if it's on this one, but I know it's showing up on test before.
Would it work in half? Like whenever you put 3 or infinity or half?
Yep.
I understand above 1 it would work, but...
Remember, for limit comparison test, the threshold's not at 1.
Okay.
Right? So you're thinking, and this is where people get the test mixed up. If it was ratio test or something like that, then your threshold's at 1, but for limit comparison test, you just have to be not 0 and not infinity.
Okay.
Yeah, if it was less than 1, then you could say that AN was like that ratio compared to BN.
Mm-hmm.
But if you're infinity, like 0.75 times infinity is still.
Yeah, half a divergent series is still divergent.
Okay. Okay, there we go.
Yeah. Right. Yeah, if the limit goes to like a positive number, you know, like a 5 or a 1/2 or something like that, then whatever they do the same thing. Either they both converge or they both diverge.
And that's the only reason when you're going when they greater than 0, right? They're both in the same.
Yes.
The other
Right. The 0 infinity cases are more directional. They look more like direct comparison tests. I have time for one more. If you guys have to be somewhere, that's okay. Let's see what we get. Okay.
Oh, gift cards.
Woohoo!
Whoa. Those loose ones.
It's gonna be a long line at lunch then.
What?
I there's gonna be a long line at lunch if I stay here.
Mm-hmm. Oh.
This is 5k plus 3 cubed. Okay. 3k plus 3? Yes. Okay.
Isn't that just alternate
It's not exactly harmonic. It's alternating. It's an alternating P series. So it does converge.
Yeah, would you just put the bottom, set it equal to, or to that 10 minus 3?
No.
Almost. The remember that the remainder term in alternating series is the small. It's the first term you leave off.
Oh, of course. Yeah.
So it's the k plus first term.
Yeah.
So ak plus 1 is going to be 1 over. Be careful here. 5 times k plus 1 plus 3 to the third power, which is 1 over 5k plus 5 plus 3 more, so it'll be 5k plus 8 to the third power. Alright, so this is what I'm going to set less than 10 to the negative 6. Okay, so you want to flip both sides? This is going to say that 5k plus 8 cubed is bigger than 10 to the 6th. Cube root both sides? What's the cube root of 10 to the 6th? 10 to the 2, right? So this is going to be 5k plus 8 is bigger than 100. which means that 5k is bigger than 92, which means that k is bigger than whatever 92 over 5 is. It's, so, it gets you a little better bound. If you use AK, you're gonna end up with more, basically one more than you need. So, the idea is what's happening to our partial sums is they're doing this, right? And the thing that we're adding up to is in the middle. So the best bound that we can get, the difference from here to the actual sum is smaller than the distance from here to the next term, right? And you're right, it is also smaller than from here to the previous term, but you see where this is a bigger estimate than this is? So because our terms are getting smaller, it's better to use the first one you're leading on.
So for like, when you're going to occupy the terms,
Mm-hmm.
you always do like a plus one.
As long as it's alternating.
That's it, that was.
So if it's just like,
If it's a series of positive terms, you gotta use the mathematical test. Yeah, if it was positive terms, if it was just the sum of 1 over 5k plus 3 to the third and it wasn't alternating, then you would need to use the integral from k to infinity of 1 over 5x plus 3 to the third. Right, and then set that less than your 10 to the negative 6. Yeah, because it's a lot easier to make an alternating series converge. They need a lot less terms. What is 92 over 5? Yeah, so we need 19 terms, right? Because round up, right? So you need 19 terms. I'm willing to bet with that one, you probably need like closer to 300. So anytime you have a positive series, your numbers are going to be a lot bigger as far as number of terms. And it's because that integral, like when you integrate 5x plus 3 to the third on the bottom, you're going to end up with something that's 5x plus 3 squared, so you're up an order of magnitude. All right, I think we're out of time. Test at 6 o'clock tonight.